Hello, and welcome to the online course on causal inference from observational studies, NICER 201 CAUSIC. We've been talking about confidence intervals and p-values. Let us now look in this session how we actually use p-values and confidence intervals for making causal inference. If we look at the p-values and the confidence intervals, we need to understand that they are meant to answer two different questions. When we get p-values, they help us to answer the question, is there a difference in the effect? So if we are comparing two groups and we are seeing whether exposure has an effect on the outcome or not, and just a yes-no answer will be something that we could get from p-values. Whereas if you have confidence intervals and you use the point estimate as well as the confidence interval, you can answer the question, what is the size of difference in effect? So what is the effect size for this study? And secondly, how precisely did we estimate this effect size from this particular study? There are various guidelines available to look at how the results of your statistical analysis in terms of p-values and confidence intervals. What has been suggested and highly recommended is that what we should be using are confidence intervals when we report the statistical results. We need to be reporting confidence intervals for the main result, which was the main hypothesis or the main study objective. It doesn't need to be there for each and every measure that we have in the study, number one. We need to avoid using confidence intervals to examine what is called as statistical significance. Since we have an interval, we have a whole range of values for the point estimate. So we have to be looking at this entire range of values which are there in the confidence interval, along with the point estimate for the measure of association or effect that we get from the study. As we had seen earlier, it could be that this range of values could all be telling us that there is a positive effect or there is a negative effect or there is an uncertainty in the actual effect. In terms of using p-values, it is recommended that p-values may be used and reported only if we have a meaningful null hypothesis. Remember that in the significance testing paradigm, we state a null hypothesis that there is no effect of the exposure on the outcome. We do a statistical test. The statistical test gives us a p-value, and based on the value of the p-value, we see whether what is the evidence to say that we can reject the null hypothesis or we cannot reject the null hypothesis. But p-values should be used only if we think that there could be really a true null hypothesis and it is not just hypothetical. When we are making inferences related to causality, related to the effect of an exposure on an outcome, it is again not just about either the confidence interval or p-value. We also need to see how the study was done. Could there be other sources of errors apart from the random errors which are signified by the p-values and confidence intervals? There could be systematic errors, confounding, selection bias, information bias. We need to consider those as well, in addition to looking at these measures such as confidence interval to help us reach the conclusion whether there is a causal relationship between an exposure and an outcome. Many a times, it is common practice to see a value written as this odds ratio or this risk ratio, this mean value is not statistically significant or it is statistically significant. That is something that we need to avoid. We do not need to necessarily dichotomize our result into statistically significant and statistically non-significant. We'll see why. So what you would usually see in these studies when you read, you may also be practicing in the same way. You may say that there was a statistically significant odds ratio of 2.8, for example, in this. Now here you would have done it because you are saying that you may be seeing that the confidence interval does not contain the null, which is again not a good practice. You may write it as odds ratio was 2.8 with a 95% giving both the 95% confidence interval as well as the p-value, which is again unnecessary. Or even many a times you would see that people state that p-value less than 0.05 was considered as statistically significant. Actually, if we do not need to resort to these kinds of statements, we do not need to say whether our results are significant or not significant. What do we need to say? So in fact, in 2016, the American Statistical Association released a statement in the American Statistician, the journal, warning against the misuse of statistical significance and p-value. Quoting the ASA statement, good statistical practice as an essential component of good scientific practice emphasizes principles of good study design, the conduct of the study, a variety of numerical and graphical summaries of data, understanding of the phenomenon under the study, interpretation of results in the context, complete reporting, and proper logical and quantitative understanding of what the data summaries mean. They say that no single index, such as p-values, should substitute for valid scientific reasoning. What it means is that when you see a p-value which is larger than a threshold, such as usually the threshold that we use is 0.05. So if you see a p-value which is larger than more than 0.05, you see a confidence interval that includes the null value, you should not be saying that there is no difference or there is no association between the exposure and the outcome. If you find two studies and you are comparing two studies, and say if one study has what's so-called statistically significant result and the other does not, then we need not conclude that the two studies actually are conflicting. What we need to be looking at is a bigger picture. So when we report, how do we actually then report these p-values and confidence intervals? In terms of p-values, again, it's not a good idea to report it as less than or more than some threshold. Whatever may be the actual value of p-value, we just say p is less than or equal to 0.05 or p is more than 0.05. Again, that is not a good practice. We actually should give the actual value of the p-value, and usually statisticians suggest that it would be good to give it up to 3 decimal places. And again, many a times you would see that people either put some asterisks or star or the underline or the bold p-values to denote statistical significance. Again, something that should be avoided. Yes, we need to be reporting confidence intervals along with the point estimate, because by putting confidence intervals, we acknowledge that we have a certain uncertainty in our point estimate. The point estimate of all the values, we say you have a point estimate and you have possible values of the estimate which are shown through this range of confidence limits. But of all these values, the point estimate is the most compatible value from our data. And values near that point estimate are more compatible than those which are near the limits of the confidence intervals. So we need to discuss the point estimate even if they have a large p-value or a wide interval. And we need to discuss essentially the actual limits of the confidence interval and make inference based on these limits. An interval that contains the null value will also often contain the non-null values, right? So you could have a confidence interval ranging from say 0.5 to say 3.2. So it contains a null value of 1. Does that mean that there is no association? Not necessarily, because not just that it contains 1, it also contains values above 1. Remember, it goes from 1 to 2.5. So it could be anything more than 1. If it's that, then we would say it as a positive effect. Here, if the confidence limit is starting from 0.5, which means it also contains values which are less than 1, which means there could be a negative. So we need to understand where we are. Is it more of the positive effect? Is it compatible with a positive effect? Is it compatible with a negative effect? How uncertain it is, how wide it is, again, whether it has practical importance or not, this range of the confidence limit. So when you are interpreting your study results related to associations and effects, remember that statistical tests should not constitute just the sole input to making the causal inference or decision about whether there is an association or effect. This arbitrary classification of results into significant and non-significant is absolutely unnecessary, and it can actually limit a valid interpretation of the data. What is important is to know the size of the effect size, the point estimate, the value of this odds ratio or the risk ratio, and the uncertainty surrounding this point estimate. Inferences should be scientific and not just merely. Hence, the decision interpret the result as having an association or an effect or not, or sometimes this decision is there to even publish or not publish the results because you are not seeing any effect that you were expecting. It need not be just based on statistical thresholds, but on the entirety of the study, on how well the study was designed and implemented and analyzed. Thank you.